Hello everyone, my name is Saritha Unnikrishnan. I'm a lecturer in the Department of Computing and Electronics in the Institute of Technology, Sligo, and I'm working as a principal investigator in the Precision Engineering and Manufacturing Materials and Manufacturing Center in IT Sligo. So today we will discuss two key technologies underlying the next industrial revolution, that is Industry 4.0, and what are the applications of these two technologies when integrated together in digital manufacturing and health. So due to the time constraints, I'll be briefly introducing machine vision, the terminology of machine vision, and what is artificial intelligence, and what are its applications in manufacturing and health. And we'll see two example PEM projects, ongoing PEM projects in this area. Machine vision is a terminology that could be backdated as far as 1930s, when the first electronic sorting machines were introduced, and those were mainly for food sorting. And those machines were using specific filters and multiple photo detectors and so on. So from 1930 towards the 21st century, a drastic transformation has been formed in this machine vision area. The terminology is very much changed right now. This is mainly due to the recent inventions in cameras, like solid state cameras, and advancements in LED-based lightings, and many image processing and segmentation algorithms, and computer-based vision systems, and so on. So due to all these recent inventions, this machine vision terminology has changed into a new term or terminology called computer vision. So there are some basic steps incorporated with machine vision, and we'll see how it works. So the major steps in machine vision are acquiring images in real time from a process. So we could consider machine vision as a technique that could replace or complement in the industry where a manual visual inspection is currently carried out for any kind of product evaluation or process evaluation. So wherever a visual inspection is carried out, this machine vision could replace that technique as an automated technique. Okay. Coming back to the steps of machine vision. So the first step is to acquire images using appropriate imaging device. It could be a camera or a microscope or an endoscope in case of a real-time analysis. Once images are acquired from an industrial process, from an ongoing industrial process, it could be a mixing process or any kind of evaluation process. So once these images are acquired, so the next step is to characterize a particular region of interest from these images based on what kind of problem we're trying to solve. If it is a defect classification system, where analysts are trying to find out defects in certain products to classify defect-free products and products with defects. So if all those are carried out currently in a visual basis, on a visual basis, that could be replaced with a machine vision technique where images are taken in real time and characterized. Like defects could be considered as the region of interest there. So these defects could be characterized using appropriate image processing and segmentation algorithms. So once these region of interest are identified, these are analyzed to see what kind of defects are. It's all based on the problem we are trying to solve. So the next step is, after characterizing, the next step is to integrate this technique with artificial intelligence algorithms. So we'll see what is artificial intelligence in the coming slides. So using AI algorithms or AI models that could be trained using these characteristics extracted from these images, and these models can be used to predict or classify the defect-free products and products with defects or whatever kinds of. It could be multiple categories. So these algorithms could do the appropriate classification or prediction, just like or similar to the visual inspection. So visual inspection is kind of subjective and time consuming, and it could be error prone. So if we replace those visual techniques with machine vision and a process control, a complete automated process control, then that could solve some of the existing challenges. And coming to artificial intelligence, this is again, I'm trying to give a very brief introduction for AI. So AI is again a terminology that was, or a concept that was introduced long back in around 1970s, but then AI went into a winter state due to lack of data. We didn't have internet, or we didn't have big data those days. So due to the lack of confidence in that concept and lack of research funding and lack of data and lack of processing power, AI actually went into a dormant state. And in the early 21st century, it again AI moved into a spring state and eventually into a summer state, and this is mainly due to the availability of huge amount of data, and which was a contribution from internet and eventually the Internet of Things. And another important aspect that made AI stronger is the current processing power available for us. So when we talk about big data, the huge amount of data that is getting generated from the Internet of Things is available for us right now. Like Internet of Things can be considered as a connection of a network of very small devices, very small sensors and actuators, up to very big devices. So these are all connected using various networks, electronics, and software algorithms. So these are generating huge amount of data in every second, and this data could be used to train AI models. And these AI models are trained for performing a specific task, and these models will act as brains inside these machines. So we call them intelligent machines, so that these machines can interact, kind of a machine-to-machine interaction with minimum human intervention. So these machines will predict whatever response we want these machines to predict. So based on the prediction we get from these machines, these could be fed back to the system, and the system could be improved every time. So that's kind of a way to make the IoT smarter. So it's kind of a closed loop system. So artificial intelligence and machine learning, deep learning are kind of a set of buzzwords that are going around from the last decade or so. And these are interconnected terms. Machine learning is a subset of AI, and deep learning is a subset of machine learning. And machine learning, in the simplest way, machine learning could be said as training of statistical algorithms to perform using data. So training statistical algorithms using a set of data based on what problem we are trying to solve. Okay, so train the models to perform a specific task, and once these models are trained to the expected accuracy or to the best accuracy, then use these trained models to perform a similar task, to redo a similar task for a new set of data. So that is the simplest explanation for machine learning. And machine learning has actually two layers, an input layer and an output layer. The input set of data is used as predictors or the input variables for the model, and the output layer will be the response that we want the model to predict. And the term deep learning comes into the scene when we add a hidden layer in between the input layer and the output layer. So this hidden layer is kind of a layer which executes a lot of computational tasks, a lot of processing. It has so many layers and interconnected layers. that is in general called as neurons, but it's actually matrix multiplication, a lot of convolutional operations that's been taking place in these hidden layers. So as the number of layers increases, as the number of hidden layers increases, the model gets deeper and deeper. So that's the difference between machine learning and deep learning. So, so the processing power is another main aspect that made AI stronger in these days, and that is made available to us by the graphical processing units introduced by the gaming industry. And this GPUs, the graphical processing units, enable parallel processing. That will help, especially deep learning model, to perform multiple memory cycles in which with less time. So it reduces the computational cost. So that's the advantage of GPUs, and that has made the applications of artificial intelligence possible and much stronger. So, so these we saw we just saw an introduction to, or we discussed machine vision and AI in general. So, how we can apply these techniques integrated together in manufacturing and health, so that we can improve the digital manufacturing applications, or we can enhance the digital manufacturing and digital health applications. So we'll see two examples that shows how we can apply these techniques. So in this slide, what we are seeing is a visual evaluation technique currently practiced in the pharmaceutical manufacturing industry. So this is just one example I'm using for this presentation. This could be, there could be similar visual inspection or evaluation techniques carried out in many areas of, in various industrial sectors. So here we can see inside a mixer an emulsion product. It is actually a cream, a moisturizing cream emulsion. Okay, it's kind of a moisturizing cream we use in our daily life. So it's an example like that. So during mixing, oil and water are getting mixed in that mixer, and what these analysts we see in the slide are doing, they are taking samples out of the mixer every 5 minutes or so, and they are looking through these samples under the microscope and trying to evaluate the product quality. So there has been a lot of research published out there that this kind of visual inspection is time consuming, error prone, and it is highly subjective. So why not we try a machine vision or a computer vision integrate with AI technique to replace this visual inspection. So this is one of the ongoing PEM projects, which is almost at a technology readiness level of 6 now. That means we have developed the basic technology using AI and computer vision. And now we are moving on to the technology demonstration and real-time implementation stage. So, so as I explained earlier, instead of process analysts or microscope analysts taking samples physically and analyzing it into the microscope at different times and different people doing it, what we are trying to do here is to acquire the images, the microscopic images in real time during the mixing process, and analyzing these samples and using image processing and segmentation algorithms. We're detecting the size, shape, and intensity and various characteristics of these oil droplets from these micrographs. And based on the characteristics of these oil droplets, the system will check if it has attained a desirable characteristics, like a desirable distribution for the droplet size or a desirable distribution of droplet count. So then these characteristics are passed through trained AI models, and these AI models are predicting if the product has reached the target quality, or is it even now unacceptable or marginal or any of the lower level quality levels. So that's one example. So due to the time constraint, I'm just quickly running through the slides. So what this picture here shows is how we are extracting the droplet characteristics from the samples and how these characteristics are fed into the models for prediction. And this is another example. So the previous one we saw was in manufacturing, and this is a health application of machine vision and AI. So this is again not a very new technology, because a lot of research has been going on from the past 10 years or so in this area, and it is an emerging technology actually, radiomics and AI-assisted image analysis for radiology. So, radiomics is kind of extracting image features from radiographic images like MRI, CT, or any kind of radiographic images. So, extracting features from these images, like it could be called as image biomarkers. So, and these image biomarkers are used to train various AI models to predict yeah, the grade of the various tumors. So, for example, what we are seeing in this slide is glioblastoma. That is one of the most aggressive brain tumors, where we can see a set of original MRI images at the bottom stack, and we can see a set of images classified by the same set of images classified by a deep learning model, that is a CNN convolutional neural network model. The model has classified high progression areas and low progression areas into two different colors, and the model has actually produced a color map so that physicians or radiologists will be able to easily or quickly identify the high progression areas and the low progression areas, and they'll be able to suggest the appropriate treatment strategy. So this is a recent research published in Nature. So our research, so one of the PEM projects that has been carried out in this area right now is in the area of sinonasal tumors. Um, and we are also concentrating on other head and neck tumors, mainly glioma, and as well as sinonasal. Sinonasal is actually a very rarely occurring tumor, and we are collaborating with the local hospitals for that. And what we are looking at is to extract image biomarkers from advanced MRI modalities. So not only looking at conventional MRI, so we'll be looking at advanced MRI such as perfusion imaging and so many other advanced MRI techniques. So how can we extract image biomarkers from these radiographic images, and how they can provide more inferences about the disease, different stages of the disease or different grades of the tumor. So. I would try to conclude now again due to the limitation of the time. So the major advantages of integrating these two key technologies in manufacturing and health are it reduces subjectivity associated with the existing conventional techniques. It is much faster, and we'll get improved accuracy, and it is overall it's a very good advancement in decision making, and ultimately it will help. These technologies will help the digitization of industries as well as the health sectors, so that it can save resources enormously. So just to mention the future of AI, even now we are in the narrow artificial intelligence state. So a lot of research right now being carried out in various universities is to progress AI to a general AI state. So that is one model. It is not enough that one model performs one specific task. So what general AI is aiming at is a particular model that could, or one single model could perform, if it could perform multiple tasks at the same time, just like we humans do. That is kind of multitasking, similar to multitasking. So if that's kind of general AI, so that kind of models are the future of AI, and that could take another 3 or 4 decades. Okay, so that's all. If you have any questions, you can ask me now, or you can email me at the given email ID. Thank you.